I'm Xiao Li. So this is my colleague B. So we're introduced. We've worked for Databricks. We worked for Spark more than 10 years. Yeah, Spark 4.1 is coming. So today we want to introduce latest features and some overview of these major features in the Spark 4.1. First, PySpark. I just want to give some updates about the number. PySpark is being downloaded in the last 12 months. More than 200 countries are downloading the PySpark and using the PySpark. And you can see the downloads, Maven, PyPy, is still growing. Like last month, the monthly downloads is more than 100 million. So this does not include the Databricks users. So Spark 4.1 has so many amazing features. Here, just like a subset. Sandy just talked about the declarative pipeline, and Zhong just mentioned this V2 in another talks. Yeah, so today we just majorly focus on the remaining ones. First, what is Spark? Spark is a unified engine across different data sets. You can read, write from different data sets. And for different workloads, SQL, ML, analytics, ETL, and you can run Spark in different environments, Yarn, Kubernetes. So first, let's talk about this one. So thank you, Apple, for contributing to this. It becomes the Spark Kubernetes operator is the official sub-project of the Spark. Extend the Kubernetes resource manager to manage Spark applications and clusters. I mean, last month, we just released 0.6 version. Please try it and use it in your production. So I think Apple is using this in their production, very stable. Then let's talk about the data source ecosystem. So 2 weeks ago, we just officially announced the GA of the Python data source API. So if you use Spark 4.0, actually you can also get a benefit. So the ecosystem is growing. We just launched the Python data source, and we realized the community is building the many different data sources using this simple API, like a LensDB, Google Sheet, Excel, Hugging Face, GitHub, just many. It's pretty simple to build a data source. You can use AI, maybe a few hours. But the biggest challenge is how to test your data source, the quality. Otherwise, code generation is pretty simple. Python data source actually is try to simplify data ingestion into Spark. You can read, write the data to this data source. It provides a uniform API. You can just Spark or read or format source. You can also use a SQL API. You can set schema, or you can rely on Spark to infer the schema. It relies on the arrow format to make more efficient data transition. And also, you don't need to learn Scala. You don't need to care about the jar dependency. It's very easy. And you can also build both batch streaming data source and then use it in the Declarative pipeline. You can use it SQL different your jobs. Databricks user, it can also integrate with the Unity catalog. The current performance actually is for most of the use cases, the performance is very similar to the Scala data sources, very low overhead, and it relies on the arrow, and also we can support the filter pushdown starting from 4.1. So we are improving the observability, debuggability for data source, for Python data source, and also we are trying to improve performance, for example, column pruning, and provide statistics to close the gap with this V2. If you're using this V2 API, so there are still some missing features we want to provide. The focus of the community is to build a rich community-driven data source, so you can directly download, use this community-driven data source directly. Very simple. You can also build yourself. Spark Connect. So this is another huge effort. Starting from 3.4, the whole community worked very hard to build this client server decoupling. Now starting from 4.0, we create this, and yesterday I tried to search. There's many different language client. For Spark community, the Apache Spark officially support SQL, Python, Scala, R, and Swift, Rust, and Go. At the same time, the third party, the contributor, is also building .NET, TypeScript, C++. Last month, the community also discussed, can we build a Scala 3.0 Connect, Spark Connect client? Yeah. So I know people are still want to use the Scala 3. Yeah, what's next? Please contribute to your client. At the same time, last month, the community also has a vote. So we want to build JDBC driver to Spark Connect server so that if I use SQL client or some tabular BI client or JDBC application, you can use like a Spark Connect server to connect to the Spark. Then we can remove the Swift server eventually. And many cloud vendors are building providing Spark Connect support. So Databricks, of course, shared cluster, a standard cluster, serverless are built on top of Spark Connect. And the EMR, Google are also providing the Spark Connect. So the community, if you want to build a Spark Connect by yourself in your like standalone clusters, you can also try to use this like open source community contributions. So they are trying to solve the different problems when you use the Spark Connect. Feel free to contribute to your Spark Connect experience. So 4.1, we are still keep improving the Spark Connect. For example, support a large local relation, and also improve debuggability, usability, the model cache, and also better coverage. All the new features provide the Spark Connect API support. So we're building so many features. Can we move faster? So in the past, actually, every release is very slow, very error prone. It takes 6 months, 1 year to release one version. We're trying to make it faster. This year, actually, we start providing the monthly preview build to increase overall release cadence. So to minimize behavior change and also provide a better documentation for all the behavior changes. So thank you, Hyojin. So he helped the community build the infra and also release a 3 preview for 4.1. So that is a very important collect the feedbacks and improve the quality. Then the next question is like, can we provide more frequent official release? So this need more discussion. Please give us feedbacks. Actually, my team members, almost everybody is using AI to write the code. So I believe for most of the Spark users, this is also pretty important. How can we make it better? How can AI generate better code for Spark application? Something we can do for sure, like a documentation, provide more use examples, like code examples, and also provide the troubleshooting, FAQ resources, and improve our error message quality. So please contribute to this. So we just mentioned the pattern data source, right? So without context, this is a new features. So AI, ARM might not know it. So if you ask ARM to generate the pattern data source directly, the code is useless. It's just like it's a wrong code. But if you provide some example, for example, this is a repo contains 5 or 6 data source examples. Actually, ARM can generate pretty high quality code for your data source. So this is just like a demo. Please try it. Yeah. And 2 months ago, we also started a vote about can we build ARM index pages for this Spark documentations. Yeah. So we are trying to make it easy for ARM to find Spark features and generate better code. So this is still ongoing. Please contribute to this if you're interested in ARM docs. And the debugging is another pain point. So I know the Spark user community members complain this a lot. Log too long, noisy, application logs, Spark logs mixed together. Spark UI is complex, hard to navigate. Metrics, too many metrics, no documentation, no clear semantics, and the error message are not standardized and not actionable enough. Spark internal has many information, but we didn't output to the log or UI. But basically, that is an opportunity. Can we make it better? Use ARM. Yeah, that is the direction. First is starting from 3.3. Actually, we are trying to move all the error message to the error class. And we also publish a guideline how to write a good error message. So community is working hard to make it, to improve it. At the same time, in 4.0, we build a feature called structure logging. So you can generate a JSON log. If you enable these features, it contain more context for each log. So you can use a Spark to read this like log files directly. You can feed these logs to the AI if you need. At the same time, if you are your PySpark, UDF, UDTF users, debugging UDF is also very painful. And so DB will talk more features about how to debug the UDF. Here, I just want to mention one, logging. You can just print and output some logs, exceptions, so then you can query in the live cluster. This will improve the debuggability a lot. This can benefit both AI and the human. So actually, this is a great opportunity. We can just make Spark simple. We should create concise AI-friendly logs for human AI to debug. And we should expose the logs in a structured, machine-readable format. And also build MCP to query runtime data. So this is still ongoing. And also we should provide AI insight directly. People don't need to use UI read log anymore. Yeah, so next is Spark Data. Yeah, so Sandy already talked about this. So I will skip. Then DB will introduce the remaining features. Thank you.
Yeah, so I'm going to talk about from streaming first. Streaming has been like grow really strongly at Databricks internally, like at least like a 60%, year to year growth. But we see some of the use case or more and more use case are, low latency use case around like 100 milliseconds. And traditionally, people might use different frameworks such as Flink to process or handle those kind of more real-time use case. And they cause a really big problem because company has to maintain two infrastructure, two different code base, two different team maybe handling like, different application. And some more logic people want to share between batch processing and streaming processing, and it's really challenging. So Databricks, we invest in real-time streaming mode to handle, the data processing for around 100 millisecond, scale. And some example are kind of like anomaly detection, fault detection, or some people use it for personalization, like a recommendation, and you want to make it high as quick as possible. Okay, so how does it work? So it's a normal streaming query. You can simply write it, and how you trigger it is that you have a processing time trigger, but if we change it to real time trigger, then it's become like real time streaming mode. So it's really simple. No API changes for user, and simply user can just reusing their existing code and make it a real time application. So internally, we have a benchmark here. So the benchmark shows significantly reduction in terms of the latency for different use case over here. And how does it work? So the high level idea is that typically we set a micro batch into like a 1 minute or 2 minutes, because as you know, like a Spark streaming is handled like a micro batch. So each 1 minute we have one micro batch. Once we finish it, we do shuffle, and then we start another micro batch. And the problem is that you have high latency plus some of the scheduling overhead in each micro batch, right? So the streaming mode is simply we make the micro batch extremely longer And during each micro batch, we continuously processing data and we implement the streaming shuffle continuously so that we can achieve like real-time streaming mode. That's the big picture on how we implement it. And it has been open source in Spark 4.1, so feel free to try it out. Okay, and we're gonna talk about some of the Python stuff. And I'm gonna talk about some of the Python UDF recently we have been working on open source and also some of the UDF debugging. So how many people here are using like a simple like a Python UDF? Okay, a lot of people. Do you like it? Slow, fast, or easy to use? I believe it's easy to use, but not necessarily fast. And it's slow for a reason. Because we traditionally use Pico to handle data serialization between JVM to Python process is slow, and we execute it row by row, and that's slow as well. So performance is not good, and it's really powerful, but slow. As we talk about, there are high serialization costs, row by row execution. There are massive overhead, especially if your Python UDF logic is really simple and quick. Most of your time, if you do profiling, you're gonna see most of your time is spent in the overhead. So let's talk about the history of Python UDF and the evolution, and we can talk about tomorrow, the future. So we have a classic UDF. It has been introduced from the beginning of Spark 0.7, how most people use. And in 2018, we introduced Pandas UDF, which use Arrow for the serialization format. It's faster and it's batch by batch processing. So you can use some of the Arrow, Pandas API to do vectorized operation. And then to address most of people who are using Python UDF, we introduced the Arrow mode. So what Arrow mode means is that we use Arrow as the data transformation transfer format between JVM and Python, so that the serialization cost is lower, but the execution is still row by row. And now we are introducing the Arrow Python UDF, which perform significantly better and also and we also allow user to do vectorized computation. So I'm gonna share a little bit more later in Spark 4.1. So here is our classic UDF. You can simply define a UDF function, have a type, and then in the Pandas year, we introduced that you can do s.str, the upper is a vectorized operation using Pandas. So basically you processing the entire vector, using vectorized computation. So it's significantly faster, like 2 times faster than the classic Python UDF. However, Pandas UDF has its own limitation. So the data would be copied into a Python process, and then we need to convert it into Pandas format, and it's basically using NumPy data format. And this conversion gonna take a lot of memory, and sometimes easily cause worm issue. In newer version of Pandas, they are trying to adopt Arrow as a backend, so that the conversion can be eliminated. But there are many types they are not supported in Pandas using Arrow backend. So what's the problem here? So Pandas has a high memory usage, and also a lot of operation is single-threaded. We want to try to avoid all the Pandas conversion. So now Arrow is a pretty well adopted in memory columnar format, and is a new standard in like a Python data ecosystem, and also even inside other community. For example, like how Iceberg and Spark integrated is using Arrow format. So here, previously we have a Pandas UDF, and now we can define similar Arrow UDF, have similar interface, and this allow us to use Arrow compute kernel natively, and most of them are implemented in C or C++, so extremely fast. And then the data would be natively using Arrow in Python side without any data copy, so you directly apply the operation. And if you guys are Databricks user, this is also a perfect integration with Photon as well. So this data can directly piggyback to Photon with the native vectorized execution. So performance is extremely fast. And for UDTF, we also add an Arrow syntax as well. And we also try to, because so many Python like a UDF type are the legacy Python UDF, low by low computation. We have pandas UDF. Now we have the arrow UDF. So it's really confusion. So we want to unify all the Python interface into single one, and we can do type inference to decide which Python UDF implementation is being used. So essentially in from Spark 4.1, we have the unified Python interface. So you can use a UDF, depending on the type, we can pick up the right Python UDF runner. And this is amazing. So what's next on the Python UDF? So currently how Spark works is that in Spark, we create a off-heap arrow badge in JVM, and then we try to serialize it through arrow IPC using a socket to Python process. And this creates some of the performance gap in terms of data copy, memory consumption. So recently we enable early cleanup in the JVM and use compressed IPC. So we found that the memory consumption is reduced to like 20 to 30%, which is awesome. And the next thing we want to work on is zero copy between Python process and JVM. This is something in our roadmap. Okay, so key takeaway. Don't use classic UDF, start to use UDF with arrow type. They provide a really good performance gain. Okay, and then another one is the Python debugging. So it's really painful. People typically do print line in the Python UDF for debugging, and then you need to search the standard out to find the log of your print line. And it's really painful because there are so many items in the print in the standard out. So now from Spark 4.1, we introduce a session-based system table containing the Python UDF log. So you can just do select star from the Python work log, and you can get all the information from the print line in the Python UDF. We are finding them out in the log. So it's really useful to find to do debugging and troubleshooting. Okay, so for data source, Sihan and Huaxin talk about this in different sessions, so I'm gonna skip it. And in Spark 4.1, we also introduced geotype. So starting 4.1, we would have a geotype inside Spark, given like a Parquet, Iceberg, Data Lake, all support geotype right now. So now our user can do something like this: join, two different location using geotype operation natively inside Spark. We are leveraging external library, and we also add a new time type. Is the type we are the time zone, and it is available in many ecosystems like Postgres, Snowflake, and Redshift. So we add a compatibility between different cloud, different vendor of the database, or different processing engines, so it's easier for data migration. And variance type, Julian talked about this in his previous session. And inside Spark 4.1, we support variance sharding. So what variance sharding does is that we automatically figure out the common data in a variance type, and then we promote it as a separate column, separate structure. So, it's provide a better compression, for example, because it's promoted as a separate column, meaning that the compression rate will be higher, and also provide us ability to do like a schema pulling, or provide us ability to do a predicate push down. So less IO require, less CPU require, and we also get some statistics. And we see the performance gain is super fast. So let's say if you use JSON type is 1, and if you use variance, we get A-type performance gain. And with variance type and sharding in Spark 4.1, we see like a 30-type performance gain compared with handling pure JSON type. So this is really amazing. And for SQL language, in Spark 4.1, we support a recursive CTE is available in many ecosystems in database. And also we are adding SQL scripting to Spark 4.1 as well. So it's allow people to write conditional for control looping, handle exception entirely inside SQL. We are writing the Python code. And it allow us to, shift from like a hybrid Python to SQL combination to use purely SQL, and it's allow our customer to adopt like a SQL workload better.